So, if we actually want to find a function for the inverse, or find like a definition for the inverse, we can use a method called switch and solve. So I'm just going to demonstrate that real quick right now. If I wanted to find the inverse of this, well, this is just a line, so I know if I reflect it, no matter what. Well, that's not a line. No matter what it looks like, if I reflect it, it'll still be a line, and it'll pass the vertical line test. So this definitely has an inverse function for all of its domain. And the first thing you do to switch and solve is change f of x to y. I think we definitely did this in Algebra 2, tiny bit in trig pre-calc, once in calculus, or a couple times. So I'd switch my x's and my y's. So now I would have x equals 5 minus 4y. So I switched my variables, and then I'm going to solve again for y. So I'll just get y by itself. That's what I mean. So, yeah, minus 5, minus 5. So I get x minus 5 equals negative 4y. Divide by negative 4. And then I get y equals x minus 5, all divided by negative 4. I can rewrite that as f inverse x. This is the inverse notation, remember? And I'm going to move the negative into the top. So you could have it like this, or you could have it like this. Those are the same thing. So I just found the inverse function. There you go. Switch and solve. That's all you're doing. It might be a little bit weirder if you had like exponents. So I'm going to maybe do something with exponents, I think. Yeah. Actually, well, this one's important as well. If I had f of x, so a new example, f of x equals x squared plus 1. This one, right now, does not have an inverse. That's because it's a parabola. However, if I restrict the domain, that's why I'm showing you this one. If I restrict the domain, then the function here is just that. So this definitely does have an inverse. So I can switch and solve. So I'll do that. So y equals x squared plus 1. Switch the variables and solve. It's important to know what the graph looks like because watch what happens. If I reflect this, it would end up there. Reflect this, maybe there, this, there. So it looks like that. Okay, so it's important to know what the graph looks like, and I'll show you in a minute. So I switched. Now I'm ready to solve for y. So I'll subtract 1, so I get x minus 1, y squared, and then I square root both sides. Remember, anytime you square root, you do plus or minus. So really, I have y equals plus or minus the square root of x minus 1. Here's the thing. This is why it's important to graph. Because we don't have a plus or a minus because of this restriction. If this restriction wasn't there, then we'd have to use the plus or minus. But we have this restriction, and it restricts us for the inverse function. It restricts us to the top half of that square root, or the top half of this. So we would just take the positive in this case. If we restricted this to less than or equal to 0, that would be this half. I'll do it in a different color. That would be this, and then when you reflect it, you would get this, right? Those are reflections of each other. And then you would take the negative part. So that's important. Still, you can still switch and solve if they give you a restriction when you don't pass the horizontal line test initially. Hopefully that makes sense. Maybe one more example real quick. Yeah, because I feel like people would get confused on this. So if I wanted to switch and solve for something like this, x plus 3, x minus 2. It's still all the same steps, so I'll change this to y. Actually, I'm going to switch it right away. So I'll have x equals y plus 3, y minus 2. And some people are like, I don't know what to do. Well, I'm going to multiply both sides by y minus 2. Y minus 2. So that goes away, and then, so I'll just have x times y minus 2 equals y plus 3. Remember, I'm trying to solve for y, so right now I'm going to group the y's. I'll distribute x, y minus 2x. Really, that's the only thing I'm thinking that I can do right now. y plus 3. Oh, now I can actually group this y and this y. So I'll subtract y. Xy minus 2x equals 3. And then add the 2x over. Remember, I'm trying to get y by itself. So I have xy minus y. I'm going to factor out a y there. That's how I can get it by itself. And then I get 3 plus 2x. Factor out a y. 3 plus 2x. And then get the y by itself by dividing x minus 1. So y equals 3 plus 2x, x minus 1, which is the same thing as f inverse of x if I wrote f of x over here. Yes, I did. All right. There you go. That's for finding an inverse using switching and solving.